All right, hello, good day, everybody. Welcome back to KodeCamp DevOps Bootcamp. Um, we've gone over a series of lectures, and our last one being on an introduction to container orchestration, where we talked a bit about the architecture of this important container orchestration tool called Kubernetes. So today we are going to look a little more at Kubernetes specifically and how it's able to manage our containers and perform orchestration activities in an automated manner for us, right? Okay. So Kubernetes manages our containers through a number of resources called objects. These resources help to create environments that the containers can run in as applications. So Kubernetes objects are the templates, are the blueprints, are um, the specifications that are used to uh, create and specify the desired states of the resources that make up a Kubernetes application. All the different components of Kubernetes that make up the applications that are deployed and run containers are what we know as Kubernetes objects. They are the fundamental, essential components of Kubernetes that represent the desired states of our cluster, of the applications in our cluster. So we'll be looking at some of the major Kubernetes objects today, and we're going to do some work with them. The first one that we have is the pod. A pod is the basic unit of a Kubernetes application. It's the simplest Kubernetes object, which actually holds one or more containers, right? When you have your containers, your application runs within a container, and your pod holds that container or a, a, a number of related containers that might need to be deployed together, right? So the key characteristics of a pod, it can contain one or more containers, and it runs those containers and holds those containers for us. And a pod can also share the same network and namespace between all the containers that it holds. Also, a pod is ephemeral in that it can be created and removed to maintain the desired state. You can remove pods, you can have multiple pods running, multiple replicas of a pod. And when a pod is removed, Kubernetes tries to, using a particular depending on the object that creates that pod, tries to create another one and maintain the desired state of the environment based on your specifications, right? So pods are basically used to group related containers that need to share resources, right? Another important Kubernetes object is known as the replica set. So a replica set is used to specify or set a specific number of pods that you want to be running at a given time. So when you deploy a container within a Kubernetes namespace with a pod, sometimes you might need to increase the number of instances of that pod that is running. Say you have an application and you deploy that application inside a container within a pod, right? And the application is serving a particular number of users, and it then reaches the limits of what the amount of users it can serve. and your users of that application keep growing, and you need to increase the number of instances of that your application, right? A replica set helps you to increase the number of the pods that are running at a given time. So it can help you to maintain high availability of your application and stability, and also helps to maintain a specific desired states of the pods. It can enforce a specific number of pods that should be running at a given point in time, so that if a pod fails, or if it's stops running, um, because of that number of pods that have been set, the Kubernetes API knows to create another pod so that you can have um that those number of pods running at a given point in time, right? Another Kubernetes object is the Kubernetes deployment, which is basically the packaged release of the application, if I can say that. So this manages the replica sets that are used to deploy your pods, um, manage the replica sets, and kind of manage everything that has to do with a particular application. That's the pods, the replica sets it needs, and the different components that make up that deployment, that application. So it manages the replica sets and provides a declarative format to creating applications within Kubernetes. It allows you to perform rolling updates, which is the system of updating that is not all at once, but rather a gradual step-by-step form of updating, maybe one replica at a time or a couple of replicas at a time, which in essence helps you to maintain stability and availability. It also helps you to perform rollbacks and ensures that the desired state of an application, the entire application, is met. Now, in a case where you have deployed your application and you want to make that application available to communicate over a computer network, that's the function of the Kubernetes service object. It exposes pods, exposes containers on a network to a network services, a network service. So it can be used to assign an IP to a pod, um, and help pods to communicate with each other within the Kubernetes cluster, and also communicate with the internet outside the Kubernetes cluster. Config maps are used to store the variables, the environmental variables of the application using key value pairs. You have the key, you have the value, things like username and the value of the username, and different environmental variables that the application might need to run. You create them using Kubernetes config maps. And in a case where the environmental variables need to be sensitive, maybe things like passwords, connections, strings to databases, SSH keys, certificates, we use Kubernetes secrets, which help to encrypt the data that is contained within its object, instead of using the plain format config maps. So secrets are used to store sensitive data for an application. Also, you have the Kubernetes ingress, which is used to manage external access to your Kubernetes pods through services. So different services can be connected to the same ingress, and ingress provides the external access to these services through over a HTTP communication. So The characteristics of an ingress is that it provides load balancing. It can be used to encrypt traffic, and can use to perform name-based hosting. It also requires an ingress controller, which performs the communication with the external sources or destinations of your communication. So it exposes services over HTTP and over HTTPS. Um, Persistent volumes are used to create persistence, creates storage locations for your Kubernetes objects, your Kubernetes applications. So a persistent volume can be used to store data, right? A persistent volume can be used to store data. It can be accessed by your Kubernetes objects to store its data, especially when you're working with stateful applications, right? So a stateful application needs to store data and needs to have access to data in order to maintain its states, to maintain its state at a given point in time. But uh, a stateless application might not need to maintain states, right? Um, so persistent volumes help to store data. So you can create a persistent volume of a particular size, and the persistent volume can now be attached to a Kubernetes pod using a persistent volume claim. So the persistent volume is the volume, and your means to attach that volume to your pod or Kubernetes object that needs to use it is through a persistent volume claim, which requests storage on behalf of the application, on behalf of a user, and binds a persistent volume to an application. Right. So to claim storage resource for a pod, you use a persistent volume claim. Okay, so a stateful set. Now a stateful set is used to is similar to a Kubernetes deployment. The difference is that a Kubernetes deployment is used when you are creating an application that doesn't need you to persist its state. Applications such as web servers, um, web servers might not need you to maintain its state, for instance. But when you're working with something like a database, you know that the data within your database needs to persist its state. If not, you can lose data if the resources go down. So you don't want to lose data. You want to be able to persist and maintain the state of that your application, right? So of that your of the pods of that application, those containers. So you deploy them with a stateful set rather than with a Kubernetes deployment. Okay. So you can also use daemon sets, which are a type of deployment that ensures that a pod or a particular number of pods, that is a copy of a pod running on every node within your cluster. If you want to ensure that Kubernetes, with every node that is created or every node that exists, your deployment of a pod, it deploys a container, it deploys a pod to every node. You use something like a daemon set. A very interesting use case of this is to deploy monitoring agents, monitoring applications. So you want to be able to, if you want to be able to have an application on every server within your Kubernetes cluster to monitor the performance of that server. Instead of manually checking all your nodes to make sure that this pod is deployed on it, you can work with a daemon set which does that deployment for you. You can also there's also a Kubernetes object called a job, which is used to um, create pods that executes specific tasks for you and run those tasks to completion. Uh, it can be used to run batch jobs or run particular jobs at a point in time. Um, if you want to have jobs that run on a schedule, you use cron jobs. The cron job object helps you to manage time-based jobs within Kubernetes, right? Okay, so those are the main 11 objects that you mostly be working with within Kubernetes. And something important that we should also know is the concept of Kubernetes namespaces, right? So a namespace just creates a virtual logical environment where you can deploy your resources, and we will look at that more later. So these are the main 11 Kubernetes objects that we will interact with from time to time. So yes. Are there any questions on this before we begin a hands-on? To just look at a few of these. If there are any questions, you can put up your hand or drop it within the chats. Hello, how come you all hear me?
Yes, sir, we can hear you.
Okay. Okay, so there are no questions. Let's take a look at some of these. Okay, so I have my Minikube cluster. Um, I have Minikube installed on my computer right now. I'm going to start that up. I actually have a cluster that I've created previously called the home lab. But if you don't have a cluster yet, you can start a cluster using Minikube starts and maybe specify a name for it using -p and name it whatever you want. Right, but I have my cluster, so I'm going to start that up again. Let's see. So it's down, the cluster is down right now. So she's starting my course cluster. Also, I have Kubernetes running. I have Docker running because this deploys it within my local Docker environment, deploys the nodes within my local Docker environment. So it's starting down up right now. I'm working with a 4-node cluster. Um, Okay, so this is my cluster. I have it running internally. I can do close this screen. kubectl. kubectl is used to execute Kubernetes commands. Used to give Kubernetes commands to your kube API server. So kubectl get nodes, right? Or you can write it completely get nodes, and it shows me the nodes I have. I have my 4 nodes here. You see this first one, home lab, is called control plane. So that is the control plane that we spoke about in our last class that holds the control plane components. And the other 3 are my worker nodes. To set this up, you do, because I've done this earlier before, but to set it up, if you're setting it up for the first time, you do minikube. This is the command for it, minikube, excuse me. Sorry about that. You do minikube starts, right? Then you can specify the number of nodes that you want. As 4, and then you can give it a name using -p. Maybe you can name it home lab. If you want to be using it for your practice, you can name it sandbox. You can name it KodeCamp. So whatever name you want to give it, you can give it, and it starts your minikube for you. And minikube also configures your Kubernetes, does your Kubernetes configuration, right? In kube/config, like it's puts the certificates that you use, that your local system uses to interact with the cluster, and puts them in a file called um cubes kube config file, right? So we won't go into that um today, but that's how it does the authentication to communicate with your cluster, right? If I do something like kubectl config get configs, get contexts, right? So you can see here that I have home lab as one of my configurations. I did grep so that it can specifically bring that out, but I also have other, because I have other contexts that I can use. So you can switch between contexts to interact with different clusters that you might have. Okay, so I believe we all have this set up now. I will start by so I'll do kubectl gets namespaces, right? If I do kubectl get namespaces, you can see that I have some namespaces that within my cluster already. But for the sake of this class, I'm going to create a new namespace, which is basically just a new environment for where I'll be deploying the things that we'll learn within this class. Now, if you don't specify a namespace, for example, if I want to see some of the pods that are running within my cluster, and I do kubectl, that's kube control, whatever, kubectl get pods, or I can do get PO as a short form. So if I do kubectl get pods and get them, it basically show me these pods. But these pods that I'm seeing are within my default namespace. That's this namespace here. This namespace, right? So they are basically sitting within my default namespace. Or if I want to get from another namespace, I can specify the namespace. Maybe dev. Using my dev namespace now and to see the pods that are in there. Okay, so you see, no resources found in this dev namespace. So basically, there are no pods in the dev namespace right now. So namespaces help to define separate environments, separate isolated environments where you can deploy resources to. So I'm going to create a new resource. I'll create it here, create by the side. kubectl creates kubectl creates namespace. And I'll name it KodeCamp, right? Because what else would I name it? I'll name it kubectl creates namespace KodeCamp. And you see, it tells me that the namespace KodeCamp has now been created. And I can come here and do kubectl gets namespaces before, which I've run here already. And we will see that a new namespace has been added called KodeCamp. This was created 12 seconds ago. That's the age. You see, it's not here. So within this namespace, I will be deploying most of the resources, right? Okay. So are we all together? Are we all together? Okay. Okay, good. So I got a confirmation. Now, looking within our let me do kubectl get all in the namespace KodeCamp. So I have no resources in KodeCamp at all. What I'm going to do, I'm going to create a pod. I'm going to create a pod. And for now, I'm just going to use a simple Linux-based text editor to do that. So I'll do nano my pod. So nano is basically a text editor. There are various text editors that are installed on that come with most distributions of Linux built in. One of them is Vim. The other one is Nano. I prefer using Nano because it's just easier for me and I like things to be easy. So I'm going to do Nano. I'll name the pod my pod, right? And my pod.yaml because I'm going to use a YAML file. I'm going to create the pod. Creating Kubernetes objects, right? There is the imperative method and there's the declarative method. What I'm doing now is the declarative method, where I basically write the specifications on a file and execute that file, right? In order to create that object. I can also create it imperatively using commands by doing something like kubectl on my nginx, for instance, and run an nginx pod, right? So using this command right here, right? I have imperatively created a pod of an Nginx instance. Nginx is a web server, basically. It's a web proxy server. It can be used as a server, it can be used as a load balancer. So I know in a lot of the classes we have, I just use Nginx, 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 and you can be wondering what's Nginx. That's what it is. Basically, it's a simple instance of a web server. It's like Apache HTTPD, right? Um, yes. So I just created a pod for an Nginx server, and I can do the kubectl get pods again in the namespace. Um, what is our namespace? KodeCamp. And oh my goodness, when I created this, when I did the kubectl run my Nginx, you remember that I did not specify namespace. So this has basically created within the default namespace, right? So if I go to the default namespace, I will see my Nginx here running 69 seconds ago. So this has created my Nginx. I'm going to delete that. Um, I didn't even spell Nginx wrong. So it has deleted that now. I'll create it again within. I'll create it within the CodeCamp namespace. CodeCamp. Let me spell Nginx correctly. Right. So if I create this now, using the run command, Kubernetes kubectl run command, um, the pod, that pod will be created within my CodeCamp namespace. Okay, so it's running. It's running right now. That so this has simply created it imperatively. I'll let me just take out in 1 minute, right? You can put up your hand or you can drop a comment. What is a possible problem with imperatively declaring, imperatively creating a Kubernetes object? What is a possible problem that can arise from that? 1 minute. So that who is that? Hello. Okay, go ahead, Michael. Just in a few minutes, just see. What's a possible problem that can come from that?
Yes, time consuming, not trackable, prone to human errors, and you will not be able to. Okay, that's time consuming, not trackable, prone to human errors, and it's it's can't actually know when you actually filling a command or stuff like that.
Okay. So the three things you mentioned are very correct. It's time, it can be time consuming. Um, but that depends. If you're working with a large in a large scale, and you have to create pods, deployments, maybe one after the other, then yes, it might be time consuming. But if you want to perform a quick action, maybe deploy an application an instance of an application quickly to test, it might not be time consuming. It might even be the faster way to do things, right? But as you realize by working in technology, it might something that you might do fast now might cost you a lot of time tomorrow, right? Something might take a lot of time to do now might save you a lot of time tomorrow. So time consuming, it depends on the perspective you're looking at. But being non-trackable is also really important. So there's no way to remember 6 months from now, 2 months from now, the configurations I used to set up this Nginx instance, right? How I set it up. So using scripts can help me to know later how something was deployed, right? And help me to have scripts and to know what the intended state might have been, for instance. Okay. So yes. So you can do it imperatively, but that's although it's fast and it's very useful, depending on what you're trying to do, it might create some problems. So that's why you can declare it imperatively using let's see nginx nginx no my pod.yaml, right? Okay. So to create an object, some things you might need, you need to set the API version, which I'm going to set to version 1. There are many versions depending on the type of thing you want to deploy. So I'm setting that to version 1. You also need to set the kind, which I'll set to pod. Your kind can be a deployment. It can be the different Kubernetes objects we just talked about are the kinds of objects you can create. So I'm creating a pod, so that will be my kind. I'll also put some metadata. This one can be used to create things like labels that will be attached to your sorry, labels that will be attached to your objects, right? So I'll set the name to maybe my pod. Maybe nginx. Maybe I can even set to set projects. Let me leave that out. Okay. So the next thing you can specify is the specifications of your container. The specifications of your pod, right? So now put the container here. And your container is going to be a list, right? Because you can have different containers. So whereas I just put the values in here, kind I put the value metadata, I also put the values. This one is like more of a dictionary type of data structure. But for this, it's going to be a list because I can have various applications inside, and each of them will be on that one list. So to do that, this is YAML, how to write YAML. To do that, I'm going to put this dash here to specify that that is the first item, the first item within the list, and I'll set the name to maybe my container or nginx container. This is just a name that I'll give the container, nginx container, right? And then I can specify the image. This time I'll set the image to nginx, but I'm going to use a different tag. Let me get a tag of Docker Hub that I'll use for this. So I'm going to Docker Hub. I want to get a different so I can use okay, I'll use this tag 1.27.0 dash alpine, right? That's the That's the version of Nginx I'm going to install. Yes, I'll leave it this simple like this for now. Um, okay, I'll just leave it this simple and straightforward for now. I'll save this file and I'll close. Right. Then I'm going to do kubectl apply to apply what's in that file. I'll do -f to specify the file. I'll do my the name of the file, my ports, and of course I'll put my namespace KodeCamp. Okay. I have a specification error in my file. Let me take this into containers instead of container. Hmm. Let me see this. I think this should work now. I'm going to try to apply it again. And the pod has been created. If I come to view the pods that I have, I'll see that I have this is the one that I created imperatively, and this is the one that I created declaratively, just commenting still created. Okay. So it's running now. I have two containers. So that's how you create a pod within Kubernetes. Okay, so you can also create um an application that will run this pod for you, right? Because your pod is basic unit of your application, right? So um I'm going to do that. I'm going to let me delete this one that I just created as my okay. So I will leave both of them running, and let me share my screen so that we can. Okay, so we're going to get into a hands-on now. I just did a quick demo on pods in particular. So getting into the hands-on, we are going to, still using this our Nginx example, we are going to imperatively create an Nginx application. So let's do that. Okay, so back in my terminal, um, first thing we did was to create this Nginx application called my pod. Let's look at the configuration again. My pod YAML. The name is my pod. I'm going to edit that. I'm going to edit that for no reason in particular. I just don't like the name because it's not descriptive enough. Right. So let me call it Nginx pod, for instance. My pod is too generic. So I'll now create an Nginx pod. Create another Nginx pod instead of updating the one we already have. That's one of the reasons you need things like um you need things like a deployment or a stateful set to manage these things for you. So I'm going to delete the um my pod, my pod. Okay. All right, so that's off now. And we have Nginx pod and my Nginx pod, my Nginx. This one was imperatively created. This other one was created using the created declaratively. So we are working imperatively now. I think so I'll be reading this out. I have created the application imperatively, which is basically running the latest version of the my Nginx Docker app. If I want to have a better look at it, what is contained within the application, I can do kubectl specify my namespace, of course, then describe, and I'm going to describe the my Nginx pod. Nope, not sure. My Nginx, right? And I can describe that. Describe, you need to, because you can describe many types of Kubernetes objects. So I need to specify that I want to describe a pod, and then it gives me all the details of this pod. This is similar to your Docker inspect, if you can remember. Docker inspect commands that helps you to see the details of the container. This shows you the details of the container using Kubernetes described. So the name, the namespace, the node that it's running on, and the content, the image. So this is the image here, Nginx image, some of the events in it. Now, if I do get the pods again, right, and I do the same command on the next one, Nginx pod, Nginx pod. The images, now you see that it's running a different image, right? So, okay. Just wanted to show us that. So now we can come to the Nginx services. Now, we want to expose this to the public, right? Want to not expose it to the public, want to expose this on a network, first of all. So to do that, we are going to need a service. Right. Get services. Get services. And we see that in KodeCamp namespace, there's no services. So these things are not exposed on the network, right? Because the service is what you use to expose on the network. I wrote that in full form so that you can see it, but I'll just be using mostly for short form going forward, which is SVC, which service basically just does the same thing. So imperatively, we can do that using kubectl, this kubectl expose command. So I'm going to do kubectl expose. What are my pod names in the first place? Get pods, please. My nginx is the imperative one, so we just keep working with that imperative. The kubectl expose. Of course, I'm going to specify that it's going to be within my KodeCamp namespace, and I'm going to expose this. I'm going to expose the pod nginx. Expose pod my nginx. And I'm going to expose its I'll specify the ports. I want to expose it on ports 80. Expose on port 80. I also have to specify the service type. So there are different service types you can use. You can use a cluster IP. A cluster IP will basically create an IP address that can be accessed only by services within your cluster. So internally, to create to expose it on your internal service in your internal within your internal Kubernetes cluster, right? So any other pod within that cluster can access it. The node pod, the node port type, that is this one, node ports, would basically open a port on your node, which is the host of that application. Wherever the pod is deployed to open a port on that node and bind that port that is connected to the ports that you specify here. So people from outside, external traffic can be sent to the node on that port, and that traffic will come to your pod. But in a case where you have, perhaps you have 600 ports running now, 600 or 1,000 ports running. Do you want to create 1,000? Do you want to create 1,000 ports, open 1,000 ports on your node, just because you want these ports to have external connection? No, you don't want to do that. So you can use the load balancer and load balancer, which will be connected to an ingress object, and the ingress object basically sends traffic. It's sort of a load balancer and sends traffic to your service, because your service will be as backends. So what we are going to do, we're going to create a cluster IP type, because that is the basic type, and open it on port 80, and we're going to deploy that. Okay, ports. I have a problem in my ports. It's meant to be 2 dashes. I have a problem in my type as well. It's meant to be 2 dashes. Okay, so it has basically exposed the pod. How did it expose the pod? It just created a service for me, the nginx service. So if I come and do this same command again to get services, I see that there's now a service created. Let's look at that service in more details by using describe and the service name my nginx, right? Okay. Mhm. Okay, so this is the IP of the service and target ports 80. And it connects to the pod, my nginx, using the labels. So these labels basically run my nginx, connects it to the pod that it's going to be exposing. Okay. So we've done that declaratively. Now we are going to do it imperatively, right? We're going to create a service object and we're going to connect it to our pod. Let's come to, we have my pod YAML. Okay. So we have my pod YAML there. Let me edit that a little. I'm going to do nano. Right. And what I'm going to do, I'm going to add a port where it can send traffic, can basically expose this pod to something called a container port. I'm going to open that here. Oh, I should take this into, I should probably take this into, so this is a list as well. Container ports to be 80, right? So the service knows to direct this to 80 on the port. Save that. And I'm going to do the kubectl and apply for that so that I can update that by -f. Apply -f to my namespace. Spec container hotspots. Okay, so I'm going to fix that. Basically told me that it doesn't know any value called ports when specifying when working with a container. So that is supposed to be ports, not ports, because I can put in many ports here. So save that again. And okay, so this is interesting. This error is basically saying that it's forbidding for me to update an already existing pod update the fields, which include this, all these things, they are fields, containers. It's forbidden for me to update the fields of an already existing pod, except fields like the container images, the init container images, the deadline seconds, the tolerations, and the termination grace period, if I'm changing it to one from a negative grace period, to update the volumes as well. And I'm currently trying to update the service, the container ports. So it's not allowing me to do that. What I need to do is to recreate instead of update. So I'm going to delete that, right? So engine export, I'm going to have to delete it and recreate it. Delete pod, my engine export. I deleted that. Let me look at this. I tried to delete again. Mistake from today. As we created it, if I um okay, so it's running. If I try to describe that, yeah, obviously to show the update of the ports. So I'm going to create some service. I'm going to do nano my service .yaml. And in light of that, I'm going to create service version 1, right? Version 1. The kind, what would kind be? To be a service kind. What is the other service named? Let me name this one Nginx service. And then, of course, I'll put in the specifications of the service. Type, I decided to use a cluster IP. And then I need to connect it to the missed something. Anyway, let's do the selector. This selector will basically look for objects with this label that I'm going to specify here, right? And see maybe maybe see let me use I'm going to add this to the Nginx app, right? I'm going to add this to the Nginx pod. It's this Nginx port. Right, this label. To look for this label, then all the labels all the applications that have that label, it's going to create it's going to connect the service to that. So I have that set up. I'm now going to tell it the ports that is supposed to open for me. So ports, this will open. Obviously ports again. It's a list, right? So I can put a name for it. For instance, call it HTTP ports. So it's a list. Then I might want to tell it the protocol to use. This takes you back to the networking class we had on I think we spoke about TCP and UDP on that in that class. So the protocol is used for communication on TCP. Yeah, I can also specify the container ports. No, let me leave that one. So this is basically the service script that I've just created. I can save this and exit. And in here I have so I can do the kube apply again. My -f my service ML injects invalid passports. Nginx service is invalid. Okay. My service. What is zero? Said something is zero and it's meant to be exports. Invalid value 0. 1 and 65, 655. Okay. So I specify the target port. Okay. Let's work on that. So there's a required value that I didn't put here, which is a required field or attribute, which is the port 80. Set that to 80. So there's the target port that you can set, and then the ports of the service. By default, if not specified, like if you don't specify the target port, the target port would just basically be defaulted to the same value as your ports. Now the target port is the ports on your targets, which in this case is going to be my Nginx pod. Yes, Michael. So target port is going to be the port on my Nginx, on my pod, right? And the port here is the port that will be exposed using this my service. It's my cluster IP, right? So I can deploy this now. Let me see. Let me save this and exit this label. Let me try and put this label on my pod and see whether it will let me do that, or if I need to recreate the pod. What did I call it? My Nginx on my pod. Okay. So I'll put this in the metadata. In the labels. Apply the service. So it has created this service. If I come to kubectl-n KodeCamp namespace get services, I can see that there's this. Which one did I create now? This one is the one I just created, has been created. Let me try and update the pod. Okay, so it lets me to change it allowed me to update the label. So I've updated that now. And if I come to, let me describe this. It's Nginx service. Yes, so the selector is this label app pod, and this label app Nginx pod. If I come to kubectl get pods. Oh my goodness. Okay. Nginx pod. Let's describe Nginx pod to see it. Describe pod. Remember, you can describe any kind of object. To describe pod, Nginx pod. And we are looking for a label. And you see this label, Nginx pod, is the same as the label for the selector app Nginx pod. So that's how we connect this service to work with this pod. And basically, this IP, when you send traffic, to this IP on the network, right? At port 80, it routes that traffic to an endpoint 10.22.26, right? It reroutes that traffic to a particular endpoint 10.224.2.6 at port 80. And what is that 10.224. It's here. It's this port 10.224.2.6. And we have the container ports. We have container ports somewhere around here. Yes, ports. The port open on this container is port 80 as well. So that's how traffic works to the pod. Okay, so that is our traffic right there. Another thing we can do is to basically create a deployment that can now hold this, right? Okay, so imperatively, of course, let's I always want to have a view of of the I always want to have a view of the objects that I'm working with, right? So I'm just going to divide this terminal. I hope it doesn't confuse anybody because I always want to have a place where I can see the objects within my namespace. So I'm just going to divide this, right? So we still have all the things we were working on before up here, right? So I'm just using this to do my kubectl. Have my kubectl get always here. Gets within my namespace KodeCamp. And I'm going to get the pods, and I'm going to get the services, and I'm going to get the deployments, right? I can write it like this, but I like to use short forms because it makes sense. So right now I don't have any deployments, right? Okay, that's fine. So I'm going to create a deployment that can hold the Nginx image. I'm going to do kubectl create deployments. Just create deploy, or you can just write create deployments, and I'll give the deployment a name. Oh, I specify the image, which would be the Nginx latest, like it's running on this my Nginx. So Nginx latest. The deployment itself also needs a name. So I can name that my Nginx deployment. Create deployments, my Nginx deployments. Nginx deployments. Deployment. And of course, I'm going to make sure that it deploys within the same namespace I want to deploy. Is that right? So I would create this. Okay. And it's basically creates this deployment for me. Okay. And if I come and do the get deployments here again, right? And I'll see there's a deployment created here. Let me look at the get pods to see what will happen there. Get pods. Did it create another pod or did it add my pod? Okay. So it created another pod. Basically, the deployment I created this new pod and basically gave it a unique name. So this pod is under deployment. This one is what I created imperatively. All right, that's fine. There is something I want to do that will really help when you're learning. How do you do that? I think it's like this. Let me see, kubectl dash n KodeCamp describe pod. Let's say describe this pod. Describe, let's say describe deployments. Describe deployment, and this is deployments, right? And if I paste that here, and I'm going to try to do dash outputs in YAML formats. Okay, so that didn't work. Let me try get deploy. QCL get deploy. Right. Okay. So if you do kubectl get deploy, and you do output dash o output in YAML formats, this will basically give you that deployment, how you should have written it to give you the deployment in YAML format. And this is basically the format you can follow to write your own deployments declaratively, right? So in case you don't know how to write it, because different objects have different API versions. Like this one now is app/v1, right? Um, pods service is just v1, right? This is not something you should go and be memorizing. Or maybe you can, you might as well, but you will get to know it in time. Pods is v1, ingress is network, something. So let me create a deployment. Okay, in this deployment here, so yeah. So basically what a deployment does, it holds your pod, right? So what are the things that's in this deployment? First of all, there's metadata here. There's some metadata here, which includes some annotations, a label, app, my Nginx pod, the name, the namespace. It has revision version. It has the UID, which is the user ID, basically on the Linux in the Linux system. It has a creation timestamp. Um, yes. So it also has something important called an important field called replica, right? Which is set to 1. Good. Now this replica, this is basically the replica set that we spoke about. So I can basically decide to have this pod. If I want this pod to have 3 instances, for instance, I can set this replica set to 3, right? Okay. Now this match label part, you see from here, this is basically the specifications of your pod, right? Sorry, not from there, from here, this spec here. This is the spec of your deployment. So you have things like the strategy for updates, for instance, the rolling strategy, max unavailable 25%, right? So you can't have more than 25% of the pods unavailable. Say if you have six replicas now, you can't have more than 25% of those 6 replicas unavailable at the same time. This deployment to keep trying to maintain that desired state of having at least 25% unavailable. It does the rolling updates for that's strategy for updating. Yes, type of updating. Yes, okay. So this is the spec, very important. This is the spec of your deployment. After the spec of your deployment here, there's this other spec here, right? And based on the indentation, right? You can see that using the YAML script format, you can see that this spec is under this deployment spec. So basically, this spec you see right here, this is your pod specification, right? So this will have your containers. It will have your ports. If there's a container port, it will be all within here, right? And yes, so that's what I wanted to show you. Okay, so I'm going to create my own deployments in here. Once again, I have my pod YAML, my service YAML. I will now create my deployment YAML. My deployment dot YAML. Yes. So creating my deployment YAML. Now I can put the API version. I already have it right here. from me, but I'm still going to type it out. Apps slash v1. If there's anybody that is following me, just drop that in the comment section and say I'm following. That's somebody that is doing this thing along with me. Just let me know in the comment section. Let me know if people are just watching film or actually doing this along. Okay, so I have deployments, metadata. I can just add maybe something like the name, which would be Nginx deployments. Yes, Nginx deployment. So nobody's coding along. I have Nginx deployments. Okay, fair point. Then I can also put in the labels. The label which will attach my pod to these deployments. Maybe I'll set that as app. What was the former label I used? I remember. App Nginx. Yeah, let me just use app Nginx. No, hold on. Nginx pod. Fine. I'm doing this because I want the service to also maybe connect to these deployments. Okay, so that being done, I'm going to set the spec of the deployments. This time, okay, let me just set it to 1. Replicas, I'm going to set that to 1. I'm going to set the strategy. Now, this strategy is how you perform updates. It can either be, it has 2 types. It can either be of type recreates, right? Or of type rolling strategy, rolling updates. So the rolling updates, if the recreate, if you have 3 instances, for instance, to take it down and bring up new ones. But the rolling updates does it incrementally, so helping you to maintain uptime. So I'm going to put this rolling updates, type rolling updates, and I'm going to set some specifications, right, for the rolling updates. Oops. It should be the max unavailable. This can be either a number or a percentage. I'm going to put it as a percentage so that within the number, it can still be effective. Max search, which I also set to 25%. Then I'm going to do templates. Still under the spec of my deployments. Templates. Now this template is basically saying what is the template of your pods. Well, that's fine. Metadata. The metadata of my pod. My Let me change this to Nginx app, right? Change the Nginx app. And I also change that in the I also change it in the service if I need to. Something I forgot in the spec is the match label. So to make sure that this deployment is able to match with the templates of the template the template of to match with pods that are created from this, I need to set the selector. So I'm setting the selector. We also sell selector in the service that we wrote. So selector, I'm going to match label, right? And what is the label I want to match? I want to match the label app, the key, and the value as Nginx app, right? Okay. So that's the same thing that we also have here on the pod template. So finally, after the metadata, we also need the spec of the pod. And containers, remember our container, the image we used last time was Nginx. Let me check. Let's check. Kubectl gets dash n gets gets pod. We have Nginx pod. Nginx pod. I want to see the image. Yeah, this is that's what I want to see. And I'm going to get the pod and get my service and get my deployments. Should I always be looking at them? Okay. All right, so I think I also have something like container ports, which I set to 80. What else did I have? Did I have anything else? I don't think so. I think this is how it was. Okay. Not like I'm specifically trying to follow what I have in my pod. Oh, this configuration. So down here, I should say container ports, right? This should be a list and ports. The other way around. Container ports. Container ports. Yes, and we have ports here. Container ports. Okay. So let's try to deploy that kubectl. Deploy it into our namespace, KodeCamp, apply. You need to spell apply correctly. Apply my deploy, right? And of course, the error creating my deployments in version 1 cannot be handled. Did I put version 1? Because okay, so let's fix this. Okay, so first of all, it says there's nothing like label, it should be labels. And secondly, I have my selector, right? If you trace it up, I have my selector under strategy. That is wrong. Selector should be under spec. So I'm going to remove this, right? And I'll save this now. And I'll try to deploy that again. Okay. So again, show me that it's a problem in spec, in selector, match label. What is the problem? It says unknown field, right? So obviously that was a mistake. It should be match labels. Save that again. Try to redeploy. The deployment is invalid. Spec container name is a required value. Really? Okay, so let's add a container name then. Let's add the container name. Let me come down to containers, that is, and put a name. Maybe I'll name it HTTP. HTTP ports. Containers. Oh, not the, sorry. I gave the port name. Sorry, it's not talking about the port name. This is fine. What is missing is the container here. In the containers, this container, I did not put in a name for it. So I have to put in a name here. I'm basically going to name it Nginx. Nginx dash pod, right? Okay, so it has created the deployment for me. I can come here and do the get deploy, and I'll see that the Nginx deployment has been created. Nginx deployment has been created. I'm now going to look at the pods that I now have. What's the pod? And I see this other deployment has been created. This other pod has been created from the deployments. So I have deployments that are managing these pods now. Let me just delete this. Okay, I'll leave them. I'll leave them there. But we know that this pod, this this pod here is coming from these deployments, and this other pod is coming from this deployment. Let's do the final thing before we close out for today, which is we're going to work with replica sets. I'm going to imperatively scale out to 3 replicas, and I'm also going to do it using declaratively using a file. So I can do it imperatively. Obviously, this is my what is the deployments? My Nginx deployments, right? So I can take that. I can do kubectl scale. kubectl scale. You know, that's scale deployments. And I'm going to scale the deployments called this is the name. And I'm going to set that to is this format still working? Kubernetes 1.0. Kubernetes kubectl scale. Three source and name. This is a strange error. Um, hmm. Okay, let me do it declaratively first. To do that, I'll just come to the deployment YAML here, and I'm going to set these replicas to 3. Right. Save that and exit, and then I'm going to apply it again. Okay, so I apply that again. If I look at so I see this has gone up to 3, right? The ready 3, sorry. Um, okay, so we now see here that there are 3 replicas. If I come to the pods, this my nginx deploy, you see that there are 3 replicas of it. So 3 pods from this. That is declarative. Imperative is giving me an error here. No objects passed to scale. What does that mean? Oh, almost got it. Replica set here. Okay. There might be a problem with the way I'm specifying it here. But that's fine. Oh, this is the correct way to write this. Okay, so this is a new error. I don't think I've come across this before. But then again, I don't usually work imperatively. But we're out of time, but I'll look more into that error. But basically, this is how you would usually scale imperatively. And if you want to do it declaratively using your YAML files, you just increase the number that is on your deployment script. So we've spoken about manifests. We've spoken about pods, we've spoken about service, we've spoken about the deployments. We didn't touch on many other ones, many other of the things that we talked about, but these are the basic important ones to create an application. We basically created deployed an Nginx application to our Kubernetes cluster now. All right, so that should bring us to the end of this class. We've basically learned how to work with Kubernetes, some of the Kubernetes objects that we'll be needing. Thank you so much for coming. Thank you for joining me, and I hope to see you in the next one. All right, bye.